Hey, Josh, if you could go through the value of thin mill coatings in relationship to concrete flooring.
Sure. When it comes to a bare concrete floor, like let's say in a warehouse or really any environment, concrete itself is reactive because it's highly alkaline. Its pH is, going to be up and around the 10, 11, 12 range. So if I have a bare slab of concrete and it's reactive, that means if anything acidic, as an example, were to fall on it, it can do damage to it. And not just battery acid, but even food grade acids, ketchup, mustard, orange juice, stuff like that. And of course, battery acid, everybody's probably seen the damage or corrosion that can take place on concrete that's bare and been exposed to battery acid. When it comes to coatings that are appropriately specified for an environment, they're going to be able to be resilient to the attack that would otherwise take place on a bare concrete floor when they come in contact. So if I have a environment where I know I'm going to have battery acid as an example, there are high performance coatings that can protect the surface so that the facility manager or owner doesn't have a lot of expense to keep the floor looking good. Anybody would say, of course, if I know I'm going to have damaging chemicals falling on the floor, I probably should attempt to contain that or keep that from happening. But the nice part with a coating is that if it's at least somewhat formulated to be resilient or repellent to the damage that would otherwise take place, then the floor won't be prematurely aging or looking bad or become difficult to keep clean. More toward, let's say, the less aggressive chemicals of food grade acids, stuff like that, that could just be a basic urethane, just a regular, I hate to say run of the mill, but let's say a very standard top coat of a polyaspartic or a polyurethane coating. Even a water base would be a much greater step ahead than a bare concrete floor to repel, again, those food grade acids. The other thing about concrete is it's porous. And porous is good when it comes to surface preparation and relying on the materials to adhere, but it's bad when it's a bare slab because if it's porous like a sponge, granted a very dense one, when I spill oil on the floor as an example, and it doesn't have to be motor oil, it doesn't have to be a fuel oil, it could be cooking oil. So the reason I bring cooking oil into the conversation is because I could have a concrete floor in a commercial kitchen, or I could have it in an oil change place where somebody maybe specifies a polished floor, no coating to protect it. That concrete is still thirsty. So beside being reactive, it's thirsty or absorbent. When the oil hits the floor, and my intent is to have that floor set some kind of an image of cleanliness, that's going to be difficult to do if it has unsightly stains. It may be clean, but being absorbent the way it is, and of course, everybody's seen an oil stained floor, whatever the oil might be, that discoloration certainly doesn't impart that the floor is clean. A coating, again, a very basic coating, all the way up to, let's say, something that's highly chemically resistant in terms of a urethane or a polyaspartic or other types of coating top coats, I'm not going to have to worry about the staining because, again, it's going to repel the chemical or the oil in this case and make it so I can use an appropriate chemical to emulsify it, recover it, and there will be no damage, lasting effect on that coating that anybody would ever know there was an oil spill. So that's why in these places where I know there's going to be oil exposure, because of the absorbent nature of concrete, a coating is going to keep that from happening.
Yeah, now that you validated the importance of coatings on concrete, and especially really understanding exactly what is this service environment. Are you talking about oil, or are you talking about just a general mill like a garage floor? They're all going to have different things that are brought to bear. But part of the other consideration is going to come down to surface preparation. And as everyone knows who's watching this video right now, that surface preparation is super critical to the success of a coating system. What methods and what methodologies for surface preparation are typically brought, let's say, when you're talking about that industrial or that food service concrete floor system before it's installed? What surface preparations are typically conducted?
Considering that concrete, as I said, and this is a good thing for adhesion, concrete is absorbent. So that means if I can make the floor clean of any surface contamination and encourage it to be absorbent or to the maximum capability that it has, when I put a liquid coating on top of the floor, because all these are fluid applied materials, They're formulated that within a certain amount of time to absorb in the surface matrix of the concrete to whatever depth it may be. It's not very much, a few mils, maybe even up to a millimeter, usually a few mils, so that's quite a bit. The idea is that there's nothing to inhibit that absorption. So when that liquid, just like oil as an example, when that coating flows into the concrete and then within a certain amount of time starts to gel and harden through reaction, it turns into a hardened layer. In most cases, we'll just say plastic, that is now fused to the surface of the concrete. So what that means is if I do it right, that coating will not come free from the surface of that slab unless the slab itself and its tensile strength is exceeded, and literally that surface delaminates, meaning the coating doesn't peel. The concrete actually breaks in order to release it. That's a properly adhered coating system. As far as the methods to make that happen, there's a couple ways to approach it. And this is usually my answer when somebody asks me the question, because there's a lot of ways to skin the cat to clean a concrete floor and make it absorbent. The first thing I would check is the coating specifications. Inside the technical data sheet, the manufacturers of quality coatings will always give some direction of the surface preparation method that's required. Sometimes they'll say the CSP, the concrete surface profile, which is more of a designation, but it's also going to specify a certain way to prepare it because that's what their formula needs in order to be able to flow within that given time that it's liquid before the set time that it starts to gel, where now it doesn't flow as much, and then harden, which means it doesn't move at all. So there's a certain amount of time I have for this liquid coating to be able to flow into the floor, and the manufacturer specifies how they would like the floor to be made thirsty. With regard to the methods that can be done, I look at it as really only two ways. It's either going to be diamond grinding or shot blasting. There is, of course, scarification, but that would be for thicker coatings, where today, I think we're talking more about thin mills, which is really anything from 40 mils maximum down to maybe 10 mils. So that would be traditional solid color or a flake floor, even a metallic maybe, down to a very basic grind and seal. Doesn't really matter what the coating is. Again, it's most important to consider the interface where the coating meets that concrete surface. With regard to diamond grinding is essentially a sander for concrete. It's using diamond pucks, diamond tools that are engineered and made to cut concrete, the same as sandpaper cuts a hardwood floor, as an example. The difference, of course, is that I'm cutting concrete, which is very hard, and diamonds, which are harder, are made to scratch the surface. The other thing that I get from a diamond grinder, a couple things that I get from a diamond grinder is I get some flattening effect from the diamond grinding. So any minor elevation inequalities, as well as severe elevation inequalities, like at joints where joints don't match up and there's almost a trip hazard, diamond grinding is going to remove those elevation inequalities so I have a more flat surface. In that process, the diamond grinding is scratching the surface of the concrete. Concrete is a mixture of sand, Portland cement, and aggregate. As long as I can make that surface open, and I know that happens when I grind it because it goes from whatever color it is to basically a white, that's all those fractured sand crystals that are now, once clean, thirsty. It also is helpful to have a grinder or to consider grinding because it's very rare that I'm going to only have floors that are just clean concrete that need to be ground and coated. There's usually going to be something on there like a cure and seal from the placement of the concrete. Existing spaces may have adhesive, may have paint, may have coatings. It just depends on what the concrete may have on top of it. Again, if my main purpose is in service of making the floor absorbent, anything that slows down the absorption of that coating when it hits the floor needs to go. Because I know that the nature of the concrete underneath whatever's on top of it, its nature is to be absorbent. I just need to make sure that I expose that layer. That's a general overview of grinding and what grinding does. And to me, it's an essential piece of the arsenal because it does so many different things to achieve that clean, absorbent state. Shot blasting is a machine, a process that will also make the floor absorbent. It is very similar to sandblasting, but dustless. or also very similar to power washing, but dry. It is a captive system that as it goes over the floor, it profiles it and cleans it by impacting the floor with steel shot. So again, instead of accelerated sand particles or water, it's a steel shot. And as that shot hits, it impacts and breaks away tiny little pieces a million times over, and then extracts the dust that's made as well as the shot that gets recovered and then recycled and reused as the process continues. Sounds very technical, but the nice part about Shot Blaster is it's self-contained. So as long as an operator knows how to turn it on, safely operate it, the process is pretty much going to take care of itself. Shot Blaster is one of those things that, again, I get questions of when would I shot blast? The first thing I'm going to say is, what does the technical data sheet say? The technical data sheet may say that it needs a shot blasting to be done because that's the level of profile and cleanliness that their coating requires. As far as a combination of the two, it's something that is starting to take on some popularity and adoption throughout the industry, where people will have both for the purpose of grinding off whatever's on the floor, also smoothing out any elevation inequalities, and then using that shot blaster to clean the floor in a way that gets all the dust that grinding and wand vacuuming alone cannot. Again, I am in service to make this floor as thirsty as possible so that the manufacturer of the coating feels confident that when I install their product, it's going to absorb and it's going to literally fuse itself to the concrete surface. But like I said, my common response to which should I use, if the product has already been specified, that is the first place to start.
Very good. So prior to the project, starting off in the surface preparation aspect of it, you've done an assessment. You're looking for any type of defects with the concrete, cracks that might be happening, that might be problematic, and other types of surface conditions that have happened. Once you've assessed that, you've gone through, you've done your surface preparation, which you just covered. Post surface preparation, what type of after the preparation assessment and testings should be conducted prior to the application of the coating system?
There's a couple different things that can be done, and this is the part that's the most important, for no other reason than to protect the contractor from any future liability for the coating. Of course, like I said, the coating, we want it to stick. Nobody wants to be called back, and so this is really going to be a big help to the contractor and worth the time, and it's much cheaper and easier to do than trying to fix the problem afterward. What I want to make sure is, again, number one, is the floor absorbent? Well, I can verify that with water. Now, some will say that's not a very sophisticated test, and I completely agree. However, if I take a cap full of water, just a bottled water, and dump it on the surface, there actually is a test that times this, but I want to see the surface darken. If the surface darkens from the water, then I know I have absorbency, which is, again, that's the key to make sure this concrete is wanting to absorb in whatever liquid I put on it. So that's one very simple test. It's easy and it really comes down to experience, but it's easy to grind a floor, vacuum a floor, think it's clean, but then find when I put water on it, it doesn't darken it as much as one would expect. Water should darken concrete. So that right there is cheap protection against future liability for lack of adhesion. The other test that can be done, and again, there's a lot of different ways to do this, is to verify how clean the floor is. Any amount of particulate that's on the surface, though I wouldn't call them a contaminant per se, anything that's on the surface that's not a part of the concrete is going to inhibit the bond to some extent. Maybe not to a point of failure or delamination, but it shouldn't be there. And I'm a realist. In the real world, it's hard to get every single speck of dust off a floor, but I would like to get it as clean as I can. So a simple tape test, blue painter's tape works great, because if I put that down on the floor and I press it into the surface and pull it up, whatever's stuck to the back of it gives me an idea of how clean my floor is. I would like to say that it's possible that nothing would stick to it. But again, in the real world, especially, on a 10,000 square foot job, it's likely there's going to be some amount of debris that is not going to be reactive. It's probably not going to cause a compatibility issue with the coating. But the manufacturers, though they do formulate in some room for error and some other particulate that's going to absorb some of their material that's not a part of the slab, if I have a failure down the road, they're going to pull up that coating and look at the back of it. Anything stuck to the back of the coating, especially if it was also on the back of the tape, it didn't adhere because I didn't prepare it properly. It wasn't clean. So the coating didn't fail, it just didn't stick. So that's a very simple test as well. The other test that can be done, which is a little more sophisticated, and I would say something that's usually going to be specified, at least in my experience with any coating, is a mention of moisture testing. Moisture testing can get confusing because there are different schools of thought currently on what is and what is not a moisture problem. Moisture is not a problem to the extent that it is static. If I have something that is causing moisture in the slab that makes it want to move, meaning from inside the slab to outside the slab, the current way of measuring it, depending who you talk to, is going to be in pounds of transmission. How many pounds of moisture is wanting to leave the floor over a given period of time? There's a test called a calcium chloride test, which is very old, but also still very reliable, provided it's done correctly. But it takes 3 days to do. So there should be some planning if I'm going to do this test. It's a valuable test. But again, it's a matter of, having a plan that I have the time to do this kind of testing. There are also digital testers which simply are placed on the surface of the concrete, and they will measure approximately the top 3/4 of an inch of the slab to let me know what the relative humidity of the surface of the slab is. This is also another area where, generally speaking, I'm looking for, on the meter I use as an example, of 6% or less. Now, that number is arbitrary, and to me it is too. It's kind of a pass-fail. However, if I find that I spike the meter, I'm going to call my supplier, because I could be on a garage floor. It's the middle of July. It's 80% humidity out. The fact that the floor is humid should really not be a surprise to me. It's going to have some humidity in the surface. Is that going to be a problem for the coating? Maybe, maybe not. The fact that it has moisture in it doesn't affect the coating. It's intent to move. And of course, we don't live in a vacuum. That happens gradually as temperatures rise and fall. So when it comes to moisture testing, my common response is to encourage people to understand enough about it to know when it's time to pick up the phone and make a call after some very simple site tests that can be done. Because as it's been explained to me, and I think everybody agrees, especially after having paid their due and failures, it's so much cheaper to pause before the material is mixed and placed than it is to fix it after the fact, because it's going to be the contractor's responsibility for not having taken any kind of moisture readings. These are the things that manufacturers tell me that a contractor can do to protect themselves. So if there is a problem, they can at least say to the manufacturer, as let's say an extension of their brand, I've done my due diligence to be successful with this. And a manufacturer is going to look at that much more kindly. Things still do go wrong, but these are the simple things that can be done to protect oneself from a failure that I've, at least, like I said, done my due diligence. Other than that, it's really, there's a lot of different tests that can be done, a lot of different ways to do the tests I've already spoken of. But for me, the simpler and easier I can do it, the more apt I am to actually do it before the material is applied.
Yeah, it's a very good point. Josh, thank you so much for covering this topic with me. And at the end of the video, I'll have contact information on how you can reach out to Josh and talk to Josh, and also follow Josh on social media. Josh, thank you so much.
You're welcome. Thank you.
Have a great day.
You too.
I appreciate you watching this clip from the latest release of Coatings Talk. Please consider joining my YouTube channel by using the link posted in the comments below. Have a great day.